Hello everyone. Today we are going to go through Lisa's workbook, which is a problem under implementation section of algorithm on HackerRank. So without wasting time, let us have a look on the problem statement. So in this problem, we are supposed to find out how many problems are spatial. What does that mean exactly? We are in a scenario where we are receiving as input a given number of chapters, and each of the chapter contain a given number of problems. And then a problem is considered spatial if the problem appear to the same number of page of the problem. Like if page 1 contain problem 1, then the problem is spatial. This one you consider page 5 contain problem 5, so problem 5 is special. The same for problem 9 and the same for problem 10. So those are the four special problems. That is why the answer here is 4. Now the next question is, how do we know the number of problem per chapter? This is the array denoting the number of problem per chapter. This say that the chapter 1 has 4 problems, the chapter 2 has 2 problems, chapter 3 6, and so on. And then now we can see that, okay, yeah, we do agree that we have 4 problems. Now how do we share those problems into pages? We have here this tree represent the maximum number of problems per page. That's why you can see, okay, this page can contain 3 problems. That's why we just put 1 2 3. This page can also contain 3 problems, but we only have 1 problem left. And then when we are at the end of a given chapter, the new chapter starts at the new page. So that's why we just put 1 year and then we started another 1 year. So given just the example we just did, how are we going to solve this? What will be our approach of solving this? Before getting deep into the scenario of solving this problem, I would really appreciate if you can subscribe to do not miss what we are doing here in terms of data structure, algorithm, and problem solving. So let's move forward and describe the approach. So our approach will be to loop from page to page. So we have like an incremental page, which will help us to move from page to page. And then once we are on a given page, we are going to find out what are the problems that are supposed to be on that page. That means from the first one to the last one. And we are going to check if the page appears like it's in between the first problem and the last problem. If it is the case, we'll return. If it's the case, we increment our result. Otherwise, we just move forward, and then at the end, we return our result. What will it look like? So the first thing is that we are going to have initial variable. The page we are starting at page 1, chapter 1. The first exercise 1, and then the result will be 0. So the first exercise. So when we are starting, we are on page 1 and first exercise. And then what we need to do at the end, we are going to return our result. So we are going to have a while loop. The while we are going to be in our while loop until we are out of the last chapter, right? So we have, let's say, 1 2 3 4 5 chapter here. So if you have not yet explored the 5 chapter, we still need to do things. If we reach the chapter 6, then we need to break things. So why the chapter is actually less or equal to array dot size. Okay, nice. Once you are here, every single step, since you are moving page by page, to increment the number of page. That means after step 1, we are going to be on step 1 we are here, on step 2 we are here, on step 3, and so on. And then what will it look like? Whenever we are starting a given process, we need to find out what is the last exercise. And the last exercise actually, if you are here, the last exercise is year plus k. That means plus the maximum number of exercise the page can support. So here you can see that the last exercise is 1 plus 3 minus 1, because we are starting and we want to count the number of elements. So the last exercise basically is first exercise plus k minus 1. But in some scenario, a page will not be able to contain all of the exercise like here. So if this number is actually greater than the maximum number of the problem a chapter can hold, then you should return instead the number of chapter. So that is why you're taking the minimum of those two elements. So after this, we are aware of the last page. We are aware of the last exercise of the page on which we are. So we can say, okay, if the page is actually greater or equal to the first exercise and the page is actually less or equal to the last exercise, then we can increment our result. Now we are going to move to the, before moving to the next step, we are going to say, okay, the first exercise will now be the last exercise plus 1. You may ask yourself another question, like, okay, if you are here, we are going to say the next exercise will be 5, and then how are we dealing with that? So whenever we are doing so, we are going to check if the first exercise is actually greater than the array of chapter minus 1. That means than the number of exercises of the chapter. That means we are at the end of that chapter. We need to move to a new chapter. And moving to a new chapter, what are we doing? We are saying, okay, the chapter is incrementing by 1, and then the first exercise is actually 1 because whenever you're starting a new chapter, you're starting at exercise 1. So now, given that this is my approach of solving this, let us go and see what it gave. Everything green, perfect. So this was my approach of solving this. I hope you do enjoy it. Feel free to give me your feedback in the comment section. I'll be really happy to interact with you regarding this. See you on the next video. Ciao.